Okay. All right, y'all. Welcome back to Finite Mathematics with Professor Griffin. We are entering a new chapter this week where we're going to be talking about some basic statistics. So this hopefully will be familiar to some of you and at least is very applicable in a lot of different settings. So as you go forward in college, you will definitely, if you do any more mathematics, you'll likely do statistics, especially if you do anything in the sciences. So statistics are highly useful and help us sort of sort out patterns and underlying trends in big data sets. That's usually where we see its greatest usefulness. So in this first section of chapter 7, we're going to be talking about how we visualize data. Okay, so just to unpack some of the terminology here. First, what we mean by data usually is either qualitative or quantitative information that is collected by researchers or surveyors, scientists, someone with a question that they are seeking some answer to. Okay, so here in this example, we have a set of data which we usually see tabulated, meaning it is expressed in a table. And this data is considered qualitative. So even though we see lots of numbers involved here, the questions that are being asked are qualitative questions. So what this table represents is the answers to the question, what is the highest degree you seek to achieve in college? And that was asked to a number of undergrads. And so some of them answered bachelor's degree, some of them answered master's degree, some of them answered doctorate, some of them answered medical degree, or some of them answered law degree, and some answered something outside of those options. Okay, so this is all the categories that they had to choose from. This is the qualitative data. And this is the number of people that said that they would be seeking a bachelor's degree, a master's degree, doctorate, medical, law, or something other. Okay. So this is just the raw count. How many people answered bachelor's, how many answered master's, so on and so forth. In the next column, we've taken this raw count and translated it into percentages. Okay, this is what we call the frequency or the relative frequency of the data. Now, it's rather simple to determine these percentages based on the data that we have. Sorry, I had to get my calculator. Okay, so let's just look at how we would find out this top percentage here, 21.1%. So the two things that we need to know is the tally for bachelor's degree, and then the total number of people surveyed. Okay, so in order to figure out this percentage, we're going to, let's see if I can get both numbers still on the screen. There we go. We're going to take the top number here, which is 29,791. And then we're going to divide that by the total number, 141,189. So what this result will give us is the relative frequency. Now, there are two ways to express the relative frequency. Either we express the relative frequency as a decimal, which is what we see here, or we can express it as a percentage. You'll see both instances throughout the homework and in life. Okay, so what we see here are percentages. In order to take this decimal and turn it into a percentage, all we have to do is take this result which we could say is 0.211, and multiply it by 100. And this will tell us the percentage, 21.1%, which is precisely what we see here. So this is exactly how we generate all these percentages you see in this column here. Take the given tally, whichever one you're interested in, and divide into it the total. Then if you want a percentage, take that result and multiply by 100. Now, percentages and relative frequencies are a more useful way of summarizing the data because we can really get a sense of what the relationship is between the numbers. Just looking at the raw data, it might be hard to immediately understand that 29,000 is 21% of the total, and 3,000 is 2.5% of the total. So that's hard to see, but also when we go to compare the numbers, here we have 59,000 and here we have 5,000, and I can see that this is 42% and this is 4.2%. That's an order of magnitude bigger. That's 10 times larger. Now, it might be hard to see that immediately just by looking at the numbers, but using percentages, we see these relationships much more easily. So it's a good reason to use percentages. Now, once we have data and we've tabulated it and figured out percentages, we can then represent it graphically. Now, there are several ways that we'll talk about representing data graphically in this section. And one of the biggest things that we have to discern is whether or not the data is qualitative or quantitative. Now here, the data is, as I said in the beginning, qualitative. Even though you see numbers, don't let that throw you off. The question that's being asked is a qualitative question. What degree are you going to seek in college? That's a qualitative question. Even though we have numbers here, which is a tally, this counts as qualitative data. And so if we are representing qualitative data graphically, we use one of two forms, bar charts or pie charts. We'll go over both of them in this section. So a bar chart is what you see here. Some main characteristics are that we have the tally or the percentage on the vertical axis, and then the categories on the horizontal axis. Okay. Now, one thing to notice is that the first thing to notice is that the bars are all separated. There's a space between all the bars. This is a big defining characteristic of bar charts. There should be space between the bars. Another characteristic of bar charts is that because it's coming from qualitative data, there's no clear way in which to order the categories on the horizontal axis. We could order them according to from greatest to least, or that's totally possible, but there's no particular reason to do that. So you see here that we've just ordered them according to the order that they appeared in the table. There's no reason not to do that. So we can. So there's no clear ordering on the horizontal axis. So we can use either the count or the percentage. Notice that no matter whether we use the count or the percentage, the overall shape, the picture, the relative proportion of the bars, each bar to one another is the same. So we get the same picture whether we use percentages or the actual raw data. Now, this is just one way to represent this data. Another way is to use a pie chart. This is likely something you've seen before. This is when we draw a circle and then represent the individual categories as pie slices of this circle. Pie charts are great because they really give us a sense of the relative proportion of the categories. We can really see that the masters and the bachelors really dominate here, with the doctorate coming in a close third and the other categories very much smaller. So let's talk about how we figure out a pie chart from the data that we have. So here I've rewritten the table with all of our categories and then their percentages. Now here in this third column, I have the 360 degrees times the percentage. And every time I've done that calculation, I've determined an angle, okay? Now, what is this angle? Let's look at, say, this one right here, 151.6 degrees. This angle represents the angle of the pie slice in the bar chart. So that's telling me that this angle right here is 151.6 degrees. And likewise with the other categories. So if I look at bachelors, I see 76 degrees, and that represents this angle right here. That's 76 degrees. Let me show you exactly how we go through this calculation so you can understand where those numbers come from. So for, say, the bachelors, we want to find the angle of the slice angle. We take the percentage of bachelors and we write it as a decimal. This is very important. So we don't use 21.1, we use 0.211, very important. Then we take that 0.211 and we multiply it by 360 degrees. So if we do that here on the calculator, 0.211 times 360 gives us 75.96. If we round this up to the ones place, we get 76 degrees. So there you can see how these angles are generated. We take the percentages, write them as decimals, multiply the result by 360 degrees, and we get an angle as a result. Now, in practice, we do not draw pie charts by hand. We use software to figure out what these, to draw these pictures for us. But it's good to know what the underlying math is. Okay, so that was qualitative data. If we're dealing with quantitative data, that is data that consists of numerical measures, as in things like length measurements or temperature measurements, or scores on a test or a quiz, for instance, then that sort of data is considered quantitative. And when we're dealing with quantitative data, there's a lot of similarity to qualitative data, but there is some different terminology and a slightly different approach. Okay, so what I have here is data from a set of 25 quiz scores, a quiz that was given in the class that was out of 10 points. I've already arranged the data from least to greatest. This makes the next part of our analysis a lot simpler, okay? So this is quantitative data. And the first thing we want to do is we're going to tabulate the data and figure out what the frequency of each score is. So what do I mean by frequency? So looking at this table here, I've arranged the scores from 0 to 10. And then I have numbers next to them that represent the frequencies. What are these frequencies? So let's look at 0, for instance. If I look up at the data set up here and I count the number of occurrences of 0 in the data set, I have 1, 2. 2 occurrences of 0. And that's why we see a 2 here in the frequency table. If I look at the number 1, I've got a 1. There's only one occurrence of 1 in the data set. If we just single out 5, for instance, I count the number of occurrences of 5. That's 1, 2, 3. And therefore 5 has a frequency of 3. So that's how this table is generated. We separate the scores from least to greatest and then count the number of occurrences of a certain score. Now, just like with qualitative data, we can represent visually or graphically this quantitative data in something that looks a lot like a bar chart. But when we're dealing with quantitative data, we call it a histogram, and it does have some slightly different features. One of the big differences between a histogram and a bar chart is that a histogram has no space between the bars. All the bars are touching each other. Now, otherwise, it's pretty much the same thing. We have the numerical measure on the vertical axis and the categories or the classes on the horizontal axis. In this case, those classes are the scores themselves. So 0 score, 1 score, 2 score, 3 score, 4 score, all the way up to a 10. The bars, in this case, are showing the frequency. So this is the frequency on the vertical axis. So for a score of 1, we show a frequency of 1. For a score of 10, we show a frequency of 5. This is what we call a histogram. So again, histograms and bar charts are very much similar to one another, but one is for qualitative data and one is for quantitative data. One has space between the bars, one has no space between the bars. But otherwise, the analysis is pretty much the same. Okay. Now, since this is a survey of statistics, we are just trying to give you a taste of all the sort of things that you'll likely see as you proceed in your college career. And what you'll certainly see, especially if you do any laboratory science classes, is the 5-number summary. Okay. Now we're going to go over exactly what all this stuff means and make it make sense. It's fairly straightforward, but there is terminology here that we have to grapple with. So first, let's talk about what a median is. Now, all of what I'm about to talk about generally is only used to analyze quantitative data, so bear that in mind. So first, let's talk about the concept of a median, and I'll show you how to find the median for a sample data set. So what is the median? For a data set, the median is a number that divides the data into 2 perfect paths. Okay, so it's the middle of the data, and that's why we have the word median. So you can think of that as like the middle of the road. This is the middle of the data set. Now, depending on how much data we have, finding the middle, the process for finding the middle can take on basically 2 different forms. First, I'll show you the harder of the 2 forms and then the easier. So here we have a small sample data set consisting of 4 numbers, 70, 74, 72, and 67. Excuse me. In order to find the median by hand for any data set, the first thing you have to do is write the data from least to greatest. So you have to write it in order. The first thing we're going to do is we're going to order the data so that we can analyze it clearly. So once we order the data, then what we need to assess is whether or not there's an even number or an odd number of data points. So in this case, we have 1, 2, 3, 4. That's an even number of data points. If it's even, then there is no clear middle present in the data. And therefore, we have to calculate the middle of the data. How do we do that? So we have 4 data points. So what we do is we take 4 and divide it by 2, because we're trying to find the middle, and that gives us the number 2. So then we find the second data point, and we also take the next one up, okay? So we took 4 divided by 2, that gave us 2, so that told us to select the second data point, and then whenever we find that first data point that we're interested in, we're always going to take the next one up in order to find the median. So now we're going to take 70 and 72, and we're going to average them. We're going to find the average value of those 2 data points. So we take 70, add 72 to it, and then divide by 2. 70 plus 72 divided by 2 is 71. And so 71 is the median for the data. So even though 71 does not occur within the data set, we still consider it the median because it cuts the data right in half. 71 falls right in the middle of the data. So everything, any number below 71, all the numbers below 71 constitute 50% of the data, and all the data above 71 constitutes the other 50% of the data. Now, this is if you have an even number of data points. The only thing we have to tweak if the total number is odd instead of even. So if I just arbitrarily add another number here, so I'm going to do 70.5. So in this case, we have an odd number of data points, 1, 2, 3, 4, 5. When we have an odd number of data points, finding the middle is simple. So in this case, the middle is one of the numbers in the data set. And as long as you've arranged the data from least to greatest, then you can almost do it visually. But here we can see that if we look at 70.5, we have 2 data points above and 2 data points below. And so that number is the very middle of the data set. And so that would constitute the median for the data. So when we have an odd number of data points, the median actually is one of the data points. It's the one that's directly in the middle. All you really need to do is take the number of data points and divide it in 2, and then find where that middle should be. So you can almost do that visually. Okay. So that is the concept of median. The median is the middle of the data. Now, once we have a grasp on that concept, we can then talk about what we call box plots and the 5-number summary. A box plot is another visualization, another way of graphically representing the data. But in this case, we represent it not with a bar chart or a pie chart, but with this box plot. And the box has a simple anatomy. We have a box in the middle with a line going through it, and then what we call the whiskers coming off the sides. So this is supposed to be read from left to right, which is least to greatest. We have the minimum value in the data set on the left, the maximum value of the data set on the right, and then these 3 numbers here, which I'm about to explain, which are called the quartiles. Okay. So quartiles are like the median. They divide the data into equal portions. Now the median, M, divided the data into two halves, a lower half and an upper half. The quartiles, there's the first quartile, the second quartile, which is the same as the median, and the third quartile. These numbers divide the data set into quarters, and that's why we call them quartiles. So the median happens to be the second quartile because the second quartile divides the data into two halves, just like the median. The first quartile separates the lower 25% from the upper 75% of the data. The third quartile separates the lower 75% from the upper 25% of the data. Finding the quartiles is just like finding the median. It's the same sort of process. Let me show you how that works. So here we have a sample data set, and here it's already been arranged from least to greatest. So we're going to find the quartiles. The first quartile we find is the second quartile, which is the median. Remember that depends on how many data points you have. In this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. That's an even number of data points, which tells me that I'm in the scenario that I showed you at first, where we have to average the two middle numbers. So what we do is we take 10 and divide it by 2, and that gives us 5. And so we count up 5, 1, 2, 3, 4, 5, and then we take the next one up. These are the two numbers that we're going to average to find the median. So 15 plus 21 divided by 2. 15 plus 21, that number in 2, and you get 18. So 18 is the median. So 18 falls right here. It splits the data into two halves. To find the other quartiles, all we do is repeat the same process, but now with the two halves of the data set. So basically, we're finding the median of the lower half and the median of the upper half, and that gives us the first and third quartiles, respectively. So to find the median for the lower half, we're in better shape than we were to begin with, because now we only have 5 data points, which is an odd number. So here we just go 1, 2, 3, and that third data point must be the middle of the lower half, and that gives us the first quartile. Likewise, with the upper half, we count up to the third, and that's 36, and that splits the upper half into two halves. So that must be the third quartile. So putting this all together, we can see from the data that the minimum value is 1. Right. The maximum value is 55. The first quartile is 6. The second quartile, which is the same as the median, we calculated to be 18. And the third quartile was 36. So these 5 numbers are the 5-number summary for the data set: minimum, maximum, first quartile, second quartile, and third quartile. Now there's one last calculation that can be useful in this context, and that's called the IQR, or the interquartile range. Something else you might see in a future class. So the interquartile range is simple to calculate. The IQR is the third quartile minus the first quartile. So for our example, IQR is equal to 36 minus 6, which is 30. So that is the IQR. The IQR is useful because it gives us a sense of how spread out the middle 75% of the data is. So it gives us a sense of how clustered or spread out the data actually is. Okay, so with the 5-number summary and the IQR, we have come to the end of section 1 of chapter 7, which is all about the basics of statistics and visualizing statistics. So please, once you've digested everything here, turn to the homework and get cracking. There's no better way to learn this stuff than to actually do the work. Y'all have a nice day.